All right, 5.6, practice your skills solutions coming at you. It's Mr. Kaczynski with you. We got inequalities in two variables now, so let's get after it. Match each inequality to the graph, or the graph to the inequality. Okay. Well, there's a couple of things I could be looking for. They're all or equal to, so they all have solid boundary lines. How about I could look at, they all have y-intercepts. Well, they have different y-intercepts. So let's just start right here. This one should have a y-intercept of 3 and a positive slope of 2. And the only one I see with a y-intercept of 3 and a positive slope, because this one, well, it's the only one with a y-intercept of 3. So that's got to be A. So graph 3. Okay, this one has got a y-intercept of 2, but really all of them do, don't they? All of the ones remaining. It's got a positive slope of 3. So let's look. Well, those both have negative slopes, and this one has a positive slope. So that's got to be graph 2. All right. How about we turn this into slope-intercept form? We can do that in 2 steps. We'll just subtract 2x from both sides, and then divide both sides by 3. So that'd be negative 2/3 x plus 2. So it's got a y-intercept of 2, as both of these do, and a slope of negative 2/3. So down 2, right 3. Yeah, that's down 2, right 3. As opposed to this one, oh, that one's also down 2, right 3. So that didn't help me at all, did it? It's just the siding of which one's shades. Well, this one, the 0, 0 is a solution point. So let's see, if I plug 0, 0 into this, I'd have 0 is less than or equal to 6, and that's a true statement. So 0, 0 is part of the solution set. So this is graph 1, which means that this last one over here must be graph 4, where 0, 0 is not a solution, because if we plug 0 in for both of these, we get this statement, which is false. All right, moving on. Yeah. Determine whether each point is a solution, or whether the point 0, 0 is a solution set of each, in the solution set of each quantity. Okay, so I mean, 0, 0 is an easy thing to plug in, because if I plug 0 into this, it's get 84x. 84 times 0 is 0. 7 times 0 is 0. And 0 plus 0 is 0. And that's always going to be the case whenever we plug 0, 0 into an equation that's in standard form, or an inequality that's in standard form. So the question is 0 greater than or equal to 70? And the answer to that question is no. Is 0 less than 7.2? Yes, it is. So 0, 0 is a solution to that inequality. Is 0 less than or equal to 75? Yes. So 0, 0 is a solution of that inequality. And is 0 greater than or equal to 3, or greater than 3? No, it's not. So it's not a solution of that inequality. Sketch each inequality on a number line. Okay, so let's make a number line. Let's throw negative 5 on there. Let's just give it a little bit of scaling. Negative 4 is bigger than negative 5. Negative 6 is less than. We're looking for all the numbers less than or equal to negative 5. So less than or equal to, first of all, it's a colored in dot, because negative 5 is part of the solution set. And all the numbers less than it are to the left on a number line. Reminder, I like to color in that number head to show that the pattern, or that arrowhead to show that the pattern is continuing forever. This one, how about we put the 2 right there, we'll put a 3 right there, 4 and a 1, with some scaling. So obviously that's going to be 2.5. We're going to do an open dot at the 2.5. Open because 2.5 is not part of the solution set. And everything to the right. All right, how about negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. A little scaling there. And this says everything between -3 and 3 inclusively. Inclusively because the or equal to -3 and 3. So I'm going to do colored in dots for that. And then everything between them would be that right there. One more of these. We'll start at -3, -2, -1, 0, 1, 2, 3. Oops, not -3, but 3. So here's 1 and here's -1. And we're doing everything between -1 and 2. So -1 and 2, but including -1 because it says or equal to. So I'm going to color that one in, and then everything in between them. There we go. So x is between -1 and 2, including -1. All right, we have this inequality, y is less than 2 minus 0.5x. Graph the boundary line for the inequality on the axis scaled from -6 to 6. So I've got from -5 to 5, good enough. All right, so our boundary line is going to have a y-intercept of 2. The slope is -1/2, so down 1, right 2, down 1, right 2. Left 2, up 1, left 2, up 1. So there's our boundary line. And I'm actually going to do a dashed line because none of the points on that line are solutions to the inequality because this is not or equal to. It's kind of like an open dot on a two-dimensional or on a number line. All right, so there, part A is done. Next, determine whether each point satisfies the inequality and plot the point on the graph you drew. All right, so let's plot the point first. So I'll do 1, 2 is right up here. There's 1, 2. And let's plug 1 into the inequality here. So let's go 2 minus 0.5 times 1. And that gives us 1.5. So the question is 2, that's the y value, less than 1.5. And that is not true. So we're going to label that as false. Next up, 4 and 0. Well, if we plug 0 into this inequality, 4 for y, or 0 for y rather, and we're going to plug 4 in. So let's do 2 minus 0.5 times 4, and that gives us 0. Is 0 less than 0? Well, let's go to that point first. 4, 0 is right there. 0 is not less than 0. It's equal to 0, so that's false. 2, -3. All right, so we'll put -3 in for y, 2 in for x, so 2 minus 0.5 times 2. And that gives us 1 is, let's see, so 2 -3. 1, 2, 1, 2, 3. It's right there. That is a true statement. Okay, so we'll mark it with a T for true. And one more. -2, -1. So -2, -1 is right here. You probably got a guess right now of whether it's true or false. I do. -1 is less than, let's do 2 minus 0.5 times our x value, which is -2. And that gives me 3. That is a true statement. -1 is less than 3, so we'll mark that as a true. All right, so notice the points above the line don't work, the points on the line don't work, and the points below the line do. Use your results from 4b to shade the half plane that represents the inequality. So that would be everything underneath the boundary line. All right. All right, same kind of idea here. Let's graph this boundary line here. So y-intercept of 1, slope of 2, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1. Okay, it is a solid line because of the or equal to. Spoiler alert, that means every point that's on the line is going to work in the inequality. And that brings us to part B here. Determine whether each given point satisfies the inequality. Plot the points with a true or false. All right, here we go. So we're going to put 2 in for y, and we're going to see if that's greater than or equal to 1 plus 2x. 1 plus 2 times our x is negative 2. That gives us negative 3. Is 2 greater than negative 3? Yes, it is. So negative 2, positive 2, that's that point right there. And we're going to say true. All right, 3, 2. 1, 2, 3, 2. I'm thinking this is going to be false because it's on the other side and the left side was true. So let's see. 2 in for y. Is that greater than or equal to 1 plus 2 times our x value, which is 3? That gives us 7. Is 2 greater than or equal to 7? No, that's a false statement. All right, negative 1, negative 1. Well, that's right on the line. Okay. So negative 1 for y. Is that greater than or equal to 1 plus 2 times our x value, negative 1? That comes out to exactly negative 1. Negative 1, is it greater than or equal to negative 1? Yes, it is. That's a true statement. Okay, so this time the point on the line worked. One more. We're going to plug negative 3 in for y. Let's plot the point here. 1, 2, 3, 4. 1, 2, 3. Ooh, see, that's above the line. I'm thinking this is going to be a true statement. Let's find out. 1 plus 2 times our x value of negative 4. And that gives me negative 7. Is negative 3 greater than negative 7? Yes, it is. That's a true statement. Use your results from 5b to shade the half plane that represents the inequality. That's going to be everything above the line where all those true points are. So everything up here. Doesn't need to be the best coloring job here. I just don't want to go to the right of that line or below the line. There we go. All right, everything for 5.6 you need to know right there. I hope you enjoyed yourself.